working on a new project with us where we're focusing on lignites after the production of hydrogen, the residual char, how we can upcycle that into useful carbon materials. That's the project that we're currently focusing on, and she's working on that project with us. She's using TGA quite extensively to study the carbon material. Can you tell a bit more?
No, what do you do with the rest? I mean, the solid after separated the gas and liquid.
Yeah, that's what I'm saying. So
what did you do with this?
What do you do with it?
Yeah, recycle those.
Yeah. So what is left after hydrogen production is a lot of carbon basically, and it's just carbon powder.
Right.
Which is not
it should be like this. Yeah.
It's just powder. But then we treat it further. We can what we can do here is add things like potassium to it, make it into a electrode material that you saw, which has higher surface area for reactions and electrochemical reactions, which are part of the batteries and supercapacitor processes.
Okay. Yeah.
So that's where it fits into. So we can sort of upcycle it by treating it chemically with different things, and then using it or making it into electrode materials, and they're then
kind of electrode things and all.
Yes.
Using for the batteries and
for generating electricity or storage of electricity in the batteries of supercapacitors.
Okay. Is it a big scale or a small scale like?
So right now this is more on a lab scale work, but this has there is enough evidence.
So it can be used. I mean, the powder can be used in
Yeah, not directly.
Electrode
not directly, but it has to be chemically processed further for doing those applications.
Okay.
Yeah. So yeah, she's the expert on that.
Yeah, thank you.
So here we just have some basic lab requirements. You need high quality pure water. So this is just that. Some treatment processing techniques to analyze the materials. This is a centrifuge, which is used high speed spinning. For separation of materials. So you can separate liquids and solids. You can separate materials with different weights using.
I use this one.
You've used it, so yeah. So it's quite useful when you're separating materials, liquids and solids, especially. As I mentioned, these are some of the furnaces that we use again for material processing, drying them at different temperatures, whether you need to dry them in inert atmosphere without oxygen or with specific gas under that. Those are the kind of furnaces. Just different furnaces and ovens for those techniques. Be mindful of that. This is another gas chromatograph system, just like the other ones there.
Or the machine is gas chromatography.
Yeah, gas chromatography. So basically, it's used for separation and identification of gases.
Different gases. Okay.
Yes. So we can actually use liquids or gases, which are then taken into the machine, and it can identify the composition.
And then separated as well.
It can identify.
Only.
Yeah, we can have. So if we have a sample which has multiple gases, it will show the difference and identify them.
Got it.
This is a supercritical CO2 extractor. It's used for CO2 separation. It can operate at very high
How do you
pressures.
present the CO2? I mean,
so CO2 is
in which form?
Right now, when we're talking about the blue hydrogen things, CO2 is captured and stored in tanks or pumped deep down into the earth.
Okay.
And where if you leave it under pressure, it's just going to solidify and transform into
Related
rocks
to that.
eventually.
Okay.
Yeah, eventually. So that's just a I think to say a preliminary or initial approach of dealing with CO2. The other way is to utilize CO2 for industrial applications. It's used in a lot of industrial processes.
Yeah, and then
so
what?
that can be stored and utilized. So once it's consumed in an industrial process and transformed into a product or a lot of polymers, a lot of chemicals use CO2 as a consumable, as a reaction material. So that's consumed in the process then, and therefore you don't need to then worry about storing it anywhere.
This is already doing.
Yeah, it's already there. This is a basically MS system. So it's inductively coupled plasma spectrometer used for identifying ion concentrations, very low ion concentrations for metals you can identify. So this is something that's used on an industrial level for identification of materials and purity samples, purity of the samples. That's just an auto sampler, so you can have multiple samples put in there, and the machine can keep doing it on its own. So those that kind of systems, yeah. But yeah, because we are more of a materials chemistry engineering kind of a group, these are the kind of systems we use, and they're very useful in identifying. So what Alicia was talking about earlier, humic acids, and ensuring they have the right quality standards for industrial scale use that the companies sell. So they have to get certified, and we can use these equipments to ensure that they have the right quality standards for their humic acids or other materials that they are trying to sell into the market.
It's a long time I have seen that periodic table. Yes.
Chalo,
No.